Hello again,
Al here.
and I'm still James. In this video we're going to go over some examples on how to show a function tends to infinity, as x does.
If you want the theory behind it, check out our previous limits video. Just to recap the definition, f of x tends to infinity as x tends to infinity if and only if for every a greater than 0 there exists a real number big X, such that f of x is greater than a whenever little x is greater than big X.
Questions on this topic can be a bit strange. A nice way to start with them is think of how you want your final line to look, and then you just go backwards from there.
So you want to end with f of x is greater than a whenever little x is greater than big X, since that's part of the definition.
In general, we'll be writing f of x is greater than or equal to g of little x, which is greater than or equal to g of big X, which is greater than a, whenever x is bigger than big X, where g is some function of x that we find or make, or both.
We choose our function g such that f of x is always going to be bigger than or equal to g of x.
For a function to tend to infinity as x does, it has to be an increasing function. This means that the function is always getting bigger or stays the same as x increases, i.e. f of x never gets smaller.
As little x is greater than big X, then it makes sense that g of little x is greater than g of big X. If we choose our value for big X so that our function g of big X is greater than a, then g of little x is definitely bigger than a. As f of x is always greater than g of little x, this means that f of x is always bigger than a.
This is a general recipe. Let's look at an example.
For our first example, we're going to look at the function f of x equals the square root of x.
Let's try to prove that the square root of x tends to infinity as x tends to infinity. You'd guess logically that f of x is going to tend to infinity as x tends to infinity, but how do you prove it?
Well, you want the final line of your proof to look like f of x equals the square root of little x, which is greater than the square root of big X, which is greater than a, whenever little x is greater than big X. The f of x equals the square root of x obviously comes from the question. We choose to leave g of x as the square root of x, as it's simple enough that we don't need to reduce it.
The square root of little x, bigger than the square root of big X, comes from the whenever little x is greater than big X statement, but with both sides square rooted.
The square root of big X greater than a comes from your choice of big X, which you will do in your working. Now to officially start the question. The first thing you should always write out is, let a greater than 0 be given. This basically states that someone is giving us a value a, and we have no say in what it is. Then you write out, let f of x be equal to the square root of x. As we want the square root of our big X to be greater than a, let's choose our big X to be bigger than a squared. Therefore, f of x is equal to the square root of little x, which is greater than the square root of big X, which is greater than a, whenever little x is greater than big X.
Therefore, f of x is bigger than a whenever little x is bigger than big X.
And then you're done, because you've proved that for every a greater than 0, there exists a real number big X, such that f of x is greater than a whenever little x is greater than big X. So by the definition, f of x equals the square root of x tends to infinity as x tends to infinity.
And don't forget that little square at the end of your proof, or QED, if you're feeling particularly fancy.
Right then, let's do a harder one.
Alright.
Let's show that the limit as x tends to infinity of x cubed plus 1 over 2x squared plus 2 is infinity.
Okay, so let's start with the let a is greater than 0 be given, like before, right?
Yeah. And then we let f of x be equal to the function we're finding the limit of. This fraction isn't so great, so we need to break it down with inequalities. A good first step would be removing the 1 from the top.
But we can't just get rid of the 2 on the bottom, as that would just make the fraction bigger.
But we can also make this fraction smaller by increasing the bottom of the fraction. If we increase each term's power of x, so that the terms in the denominator all have the same power of x.
Oh, so we can change the 2 to 2x squared.
Yeah, and then we can just simplify the fraction to x over 4.
So we choose our g of x to be x over 4. If we choose our big X, so it is 4 times bigger than a, then our g of x is always going to be bigger than a.
Then from that we can say that f of x is greater than or equal to little x over 4, which is greater than big X over 4, which is greater than a, whenever little x is greater than big X. And so once again we can say, therefore f of x is greater than a whenever little x is greater than big X.
And we're done again. I hope this video was helpful. If you would like more questions like this answered, we have more on our website with work-through solutions, as well as a bunch of other videos, some like this one and others not so much.
See you next time.
Have a good one.